Hello, my name is Gustavo Rodriguez.
I'm Chris Ray.
And I'm Eduardo Aguayo.
And we are recording for exam number 2 extra credit. And all the tables referenced in this can be found in your Principles of Structural Design textbook. So without further ado, let's get right into it. So we designed the column with these known statements. So design a 14-foot simply supported southern pine number 1 column with these givens: dead load of 1400 psi, a live load of 1800 pounds, and then a snow load of 2100 pounds. So the first step in solving this problem is you have to find the design values, adjustment factors, and load combinations. So for the sake of the video, we went ahead and solved for these design loads with the given statement. So our 5,940 pounds will be our control. And after this, we will find for the adjusted factors. First, we have to find F prime C parallel with this given statement. CM, CT, as CI, we noted up here that we're going to assume that we're going to equal 1. And we're also going to assume that this is for occupation. So with that being said, CP we're going to neglect due to the stability factor. That being said, F prime C parallel will equal, for phi will equal 0.9, and that can be found on table 6.4. FC parallel is 1,850 psi. That one can be found on B3. And then for lambda, we'll be using 0.8. Like we said, we can find that on table 6.2, and we're also going to say that because we're assuming it's for occupation. For KF, we're going to use 2.4, and that can be found on table 6.4. This will equal out to 3,197 psi. We will then have to find E min, which is our modulus of elasticity. E min we figured to be 620,000. That one can be found on table B3 as well. Phi will be 0.85, and that one can be found on table 6.4. And then 1.76, which is our KF, can be found on table 6.3. E min will equal 927,520 psi.
Next, we'll find the area required using the formula PU over F star C parallel. That equals 5940 pounds over 3197 psi, which gave us the 1.86 inches squared. We multiply it as a rule of thumb to get 3.72 inches squared. Next, we'll assume the size for the column is a 4x4, and from table B.1 we'll find the area of a section. The area is 12.25 inches squared, with the dress size being a 3.5 by 3.5 inch column. Next, we'll check the KL over D, which equals 1.0 times 14 times 12 inches over 1 foot for our conversion factor, all over 3.5 inches. This gives us 48, which is less than 50, because we want our KL over D to be less than 50, so it's okay. Next, we'll find the column stability factor. Doing that, we'll use the formula FCEN equals 0.822 times E prime min over KL over D squared, which equals 0.822 times 927,520 psi over 48 squared. This gives us 330.91 psi. And then we'll next find our beta, which is FCEN over F star C parallel, which is equal to 330.91 psi that we just found over 3197 psi, which gives us a beta of 0.104. Next, we'll find our column stability factor, which is 1 plus beta over 2c minus square root of 1 plus beta squared over 2c minus beta over c. We're going to use c equals 0.8 for the sawn lumber found on page 142 in your textbook. And this comes out to equal 1 plus 1.104 over 2.8 minus square root of 1 plus 0.104 squared over 2 times 0.8 minus 0.104 over 0.8, which gives us a column stability factor of 0.113. So we're going to check the 4x4, and then we'll use F prime C parallel times CP, or equals CP times F star C parallel, which is equal to 0.113 times 3197 psi, which gives us 361.26 psi. And the area required for the 4x4 is the PU over F prime C parallel, which is equal to 5940 pounds over 361.26, which is equal to 16.44 inches squared, which means this is no good, and we'll have to reiterate because the area required is a 12.25 inches squared, and that's to be a bigger number.
So now, since we know that the column size 4x4 did not fit the qualifications, we went and assumed a bigger size, so we're going to assume a 6x6. So from table B1, the area of a section for a 6x6 is 30.25 inches square, and the dress size is 5x5. So we went ahead and checked KL over D, and after plug and chug, it's going to equal to 30.5, which is less than 50, which is perfect, since KL over D is supposed to be less than 50. After that, we find FCEN, and we plug and chug 8.22, E min prime, KL over D square. After plugging and chugging, we get 819.59 PSI. Solving for FCEN, we plug and chug to find beta. Beta is gonna equal to 0.26, and then after we find beta, that's when we're gonna solve for the column stability factor, CP. Using that equation, C equals 0.8 for saw lumber, as we said in the previous part of the problem. So solving for the column stability factor, CP equals 0.24 for a 6x6. So now that we have the column stability factor, we're gonna plug that into the F prime C parallel. So that's gonna be the column stability factor times F star C parallel. That's gonna give you 767.28 PSI. So now that we have that, we're gonna solve for the area required. So it's PU over F prime C parallel. That's gonna plug and chug, so that's gonna give you a 7.74 inch square, and that is the area required, which is okay, since the area allowed for a 6x6 is 30.25 inches square.